Hey everyone, welcome to Friedrich VRP's Installation and Best Practices webinar. Thanks for taking the time today to be with us. My name is Peter Yadachi and I'll be going over some VRP installation essentials necessary to be successful and install the VRP product. Next, we're going to go over some VRP case studies. The VRP is an amazing product and it's very unique, so there's special considerations to be aware of. We'll go over the importance of air infiltration and envelope pressurization and to avoid some pretty big pitfalls. Finally, we're going to take a look at the VRP startup program, the process we use to ensure success on each VRP project. Some housekeeping items, please hold your questions until the end for our Q&A session, or you can just simply type them below in the chat and we'll answer during our QA session. All right, everyone, let's go.
So I'm pretty sure if you made it this class, you're already familiar with our VRP line, but it doesn't hurt to go over it real quick. So the VRP is our flagship products. We're talking about VRF performance in a single package simplicity, all inside one box. So it comes with our precision inverter compressor to giving you guys up to 20 SEER in efficiency, and heat pump operation down to 0 degrees. The fresh air system does comply with ASHRAE 62.1, is filtered through the MERV8 filtration system, and can bring you up to 70 CFM of fresh air. On the 1 and 2 ton, you're going to get 35 or 70 CFM fresh air. On the 3 ton, you're going to get up to 130 CFM. The true sophisticated humidity control system with the onboard sensors, humidistat, and optional reheat is going to help to keep your customers super comfortable. The product is available in a 12,000, 24,000, and 36,000 BTU models. So at first glance, the VRP looks like a pretty easy unit to install. You got a closet, you got the unit itself, you have the access panel and the door, and then you have our wall plenum and our louver. So it is extremely important about how the wall plenum and the louver is installed. So we're going to take a green or an energy efficient building, and we're going to cut some pretty large holes into it. So it is extremely important to follow the recommended steps that we're about to go over when sealing the plenum. So let's start to take a look at cutout sizes and rough-in measurements. So the VRP comes in a couple different chassis sizes. Okay, we're gonna go through them one at a time here for you. So first thing we're gonna take a look at is a 12,000 BTU, what we call an A-style chassis. So if you're gonna order a A-style chassis, you're gonna look at a width of 28 and an 1/8 inches wide for the rough cutout, 3 inches from the finished floor. Very important, about 3 inches from the finished floor, that you take in consideration any sort of decking or any sort of material that you're going to put on top of your wood framing to ensure that you meet that absolute 3 inches from the finished floor height. And then as far as the height is concerned, we're going to go 32 1/4 inches. Now, like I said, this is for the A model. Another important thing that we want to make sure that we take into consideration is the depth of the plenum. So it's available in 4 to 8 inches or 8 to 14 inches. And basically what you're looking at for depth there is from sheeting to sheathing. So if you were looking at a sheetrock wall to an outside cutout where there's going to be a brick or a stone facade put on the building, you're going to go from the sheathing on the outside, and that can be it could be your construction board or whatever material they're using, to the inside of the sheetrock, your complete finished depth. Now let's take a look at a B unit. So we got pictured here 24,000 BTU B style chassis. So we're still looking at the same 28 and an 1/8 width, same 3 inches from the finished floor, but your height is going to change. Your height's going to change to 42 1/4 inches. So same rules apply to the depth of the plenum, 48 or 8 to 14 inch openings. So what I've done here is I've overlaid the 24,000 BTU and a 12,000 BTU unit, or an A-style chassis and a B-style chassis. But what would happen if you had a mix of 12,000 BTU units and 24,000 BTU units? And let's say you wanted to make sure that the louver was the same size as it goes through the side of the building. So in order to do that, you can order a 12,000 BTU unit inside a B-style chassis. Okay, so and your framing dimensions is still going to be for your 24,000 BTU B style. So you're looking at 28 and an 1/8 inches wide, 3 inches from the finished floor. And here's your A measurement, 32 1/4. And then it's just an additional 10 inches. So that's how we come up with that 42 1/4 inches. So, and how we do that is we attach a splicer plate here to make up for that. So the factory installed splicer plate, 10 inches, is the adapter element that when ordered with an A-style chassis, will make up the difference so that it'll fit inside a B-style plenum. So installing the 36,000 BTU unit or the 3-ton inside the C style chassis, uh, same rules apply with installation, just a lot larger of a unit. So as far as the width, 33 inches. This unit is now 4 inches from the finished floor height and a height of 52¼ inches. Same plenum depth, 4 to 8 or 8 to 14 inches. So once the rough-in dimensions are taken and the hole is cut, you definitely want to double check to make sure that you got a rectangle. So in order to do that, you're going to use a tape measure and you're going to draw it and you're going to take a cross measurement of each of the corners. And what this is going to ensure is that you have a rectangle and not a trapezoid. So you definitely want to make sure that you got your 3 or 4 inches from the finished floor height. Otherwise, you're going to have a really rough time pushing that unit into that plenum. And then you're going to make sure that your your rectangle is plumb. So what's going to happen is that if your cross measurement is off, when you go to install the plenum, it's going to bow in certain places. Either that, or when you try to marry the two plenums together, you're going to have some pretty large gaps. So this cross measurement here is probably the most critical measurement inside in the unit. Second most critical is to make sure that the 3 inches from the finished floor or 4 inches from the finished floor measurement is done appropriately to ensure that the plenum fits in nice and snug and the unit fits in into the plenum nice as well. So once your flashing is applied, now you're ready to install your outer plenum. So typically with plenum installations, this is where we're going to create the seal in the building. You know you've done it right when the contractors come to you and they say, man, it took me 4 tubes of silicone to seal this unit. That's how you know they did it right. And let's go over why. So the first thing you're going to do is you're going to caulk all the sides of the flanges. The next thing you're going to do is do all the corners and then run a half bead of sealant completely around the plenum. So you are basically sealing the flange to the outside of the sheathing. You're sealing the corners so that this way that the metal bends are also sealed. And you're creating a nice thick bead around the center of the flange to allow it to seal up against the building. Now, if you're loose or that when you're starting to fit that plenum in, you don't got a real good tight fit, this is the time when you want to tell your contractor to start putting some shims in and to make sure that you got a good seal on the outside, in the outside structure of that wall. So if you do happen to make your measurements pretty spot on, it might be a little bit of a tight fit and you can use a rubber mallet to lightly tap the plenum into place. So you can see in the picture here that when your cutout is not really square, or there's somebody with a rogue sawzall trimming all the sheetrock, that you're going to get some pretty decent gaps here. So to draw your attention to the picture in the center, this is a closet installation that when we turn the lights off, we can look out and we can see the parking lot. What this is going to do is cause massive infiltration into that space. So it is once again very important that we maintain the dimensions in order to get a proper seal against that building. So what happens when those gaps are way out of whack and the sheetrock's already up and you guys are facing a problem where you guys are seeing what I'm looking at here? Probably the best thing to do is to get any spray foam or some filler insulation pink panels and just start to insulate around this unit, because unfortunately there's no real way to fix this besides disassembly, besides uninstalling the unit, taking the unit out, uninstalling the plenum and starting from square one again. So if everything is extremely out of tolerance, then you might have to go back and you might have to uninstall that unit. So the inner plenum is installed pretty much like the outer plenum. So you're going to take your sealant. Remember, if it's not 4 tubes, you maybe didn't do it right. So you're going to take your sealant, you're going to apply it to all sides of the flange to get a nice good seal against the sheetrock or whatever finish wall they have inside that closet. Then you're going to put the sealant on all the quarters and you're going to run a nice thick 1/2 inch bead completely around the plenum. Now, once you marry the inner and the outer plenum together, you're going to take a drill bit and you're going to drill 2 screw holes 4 inches from the top and bottom of the corners, right? And then once you have those pilot holes, that's when you're going to drive, your screws through both plenums and secure them to the wall. Now comes to the installation of the baffle. So on our A style or 12,000 BTU units, there's really only one position for the baffle. So on our B style or 24,000 BTU chassis size, you're going to notice that the inner plenum has two locations for the baffle, and I've highlighted them here. So the yellow position would be if it is a B style chassis on a 12,000 BTU unit, and the red location is a B style chassis on a 24,000 BTU unit. So shipped separately is your plenum divider plate. So how to install this is exactly like the picture shows. So you're going to take the divider plate, you're going to put it on top of the plenum. There are two 1/4 inch screws that sit on the retainer plate, and then you're going to take the baffle and you're going to push it up against the louver, and then you're going to tighten down on the 1/4 inch screws. So when the installation is all complete, you should have a completely sealed plenum, right? So on the outside of the building, you have the outer plenum caulked and sealed. On the flange, you have that pressed up against the outside of the building. On the inner plenum, you have that also caulked on the flange, and you also have the caulk that fits in between both of the plenums, and the caulk that fits between the outer plenum and the building. On top of that, you have your baffle plate installed, and it's pushed all the way up against your louver. And what this is going to help is this is going to help create a seal to negate the amount of infiltration and recirculation that we have going into the unit. So recirculation is probably one of our biggest issues. So let's take a look a little bit into that. So the baffle is designed to separate the cool condenser inlet and the hot exhaust outlet. So you can see, like as happened in the picture here, the outdoor air is going to come in through the top of the unit. It's going to pass through the fan and the coil, and then it's going to exhaust the hot air that comes out of it. So if you happen to be on a first floor and you can look through the louver, like the picture that shows on the right here, you should be able to see the top plate of the baffle that extends all the way across here. So the separation between the outdoor air and the exhaust air is extremely critical. And if you don't maintain that separation, you're going to have a lot of problems down the line. So some examples are high head pressure, poor unit performance, having your exhaust air leak into your fresh air, and most importantly, premature failure, right? And what we like to call in Friedrich this is recirculation. So that is when your condenser air gets recirculated back into your outdoor air. So the main proponent how this happens is when the baffle is not fully extended. So you see a picture here that this is a friend of mine showing me that, well, a couple different things, but I think the main thing that he's trying to show me is that there is not a separation between the indoor between the outdoor air and the condenser exhaust air. So this baffle plate here is not fully extended. So to correct this, the 1/4 inch screws would have to be loosened, the plate would have to be pushed all the way against the louver, and then retightened. So another problem could be the position of the baffle. So you can see here I got a 12,000 BTU unit and a 24,000 BTU unit, and these are all B-style chassis, right? So you can see that the line here that I drawn in red is where the baffle position would go, or the lower position on the inner plenum for a 12,000 BTU unit. So, and that's really where the difference is when you're positioning that baffle. So the 12,000 BTU, the baffle goes on the bottom, and on a 24,000 BTU, the baffle goes on the top. And think about it that it goes on the top because there's a lot more coil area because there is a larger unit. Now, if you happen to look through the louver on a B-style unit and you happen to see the spacer plate, then that is a very clear indication that your baffle is inside the wrong position. The only way to really remedy that is to uninstall the unit, take the baffle, drop it down to the next position, and then reinstall the unit. So once you have the baffles, louvers, and plenums all properly installed, now it's time to put the unit into the sleeve. So make sure you guys are using proper PPE when handling the unit. The 3-ton VRP can weigh up to 330 pounds. So heavy that we have to put casters on it to help you maneuver it. So easiest way to do this is to get some non-petroleum lubricant and apply it to the gasket. And what's that going to help to do is when the unit is pushed into the plenum, it's going to help to create a nice seal there. So the preferred method for the 12 and a 24 is to walk the unit on the rails to the face of the plenum and then apply even force as you push the unit, jostling it back and forth so that it seals fully into the sleeve. So you know that you've gone all the way when the top of the unit hits the wall. So this is going to guarantee us that we're about 2 inches of penetration of that outer lip that you can see inside the picture here, which I'm putting my mouse cursor on, to make sure that there's a complete seal all around the unit. And with a complete seal all the way around the unit, you should not see any light showing through the gasket. So you can see the picture inside the center here that there's an outlighted light that could be seen through that gasket. The pictures on the left here, you can see that there is some visible light that is showing through here, and these are going to cause you drastic infiltration issues. So if you are starting to see this light showing going through the gasket, pull the unit back out, check the integrity of the gasket, making sure that we didn't roll the gasket or that it hasn't been compromised in any way. The 36,000 BTU unit installs a little bit different. So in order to install the 36,000 BTU, you're going to take the unit and you're going to push it up against the plenum. Once it's on, you're going to remove the panels, and you're going to have to reach up and over the condenser coil. And what you're going to find is these two latches. So you're going to take the hooks and you're going to put them on the brackets that are on the plenum, and then you're going to pull back on that fastener handle towards you. And what that's going to do is that's going to pull the unit into the sleeve and to help to form that seal. So same principle applies. Once you pull both of the handles back and they are sealed and seated, you should be able to look on the outside of the unit and there should be no visible light there. So that wraps up all of the key installation points. I could tell you from my experience in the field, of all of the problems that we have, over 90% of the problems could have been avoided with good installation practices. And I can tell you that when you adhere to the IOM and the guidelines and all the material that's inside our training, you're going to see your VR properties do very well. But unfortunately, when we don't follow what we're supposed to do, things can go really wrong. So a couple quick pictures of some of the good ones that we've experienced in the field. So now it's time to move on to the two biggest case studies that we have regarding infiltration and exhaust air. So we talked about the importance of getting a good plenum seal and a good envelope seal, right? So if we don't, you're going to get a really bad infiltration problem. So what is infiltration? Infiltration is the unaccounted for air that enters a space through openings of the VRP. And we just went over a whole bunch of good installation tips to make sure that we minimize the amount of air that's going to be passing through that plenum. So first case study example you can see here, I have a humidity percentage of 66 and a 70-degree dry bulb. So it's a little humid inside this space, and we're going to try and figure out why. So lo and behold, with an infrared camera, you can see that we have some pictures here. It's pretty close to what it is outside. So you can see that there's a lot of infiltration coming through, especially picked up by the FLIR camera. And you can also see, as we go down the side of the unit, just how bad this installation is. And you can see that this is providing absolutely no sort of sealing element to the VRP. So as this fan turns on and it creates a negative pressure inside that cabinet, it's going to suck air from every single one of these points rather than to return air from the room. So here we are again. Why is it so humid in each one of these rooms? We're looking at 64% relative humidity. I got a dew point of 60 degrees. My thermostat is bottom out. This unit is running, and we are just not able to make the space comfortable. And more of the same thing of what we saw on the last slide here, just really bad installation practices. You can see here on the picture on the left how you can just about see the outside, all of that light shining through. No seal between the flange and the sheetrock. This unit appears that it is just floating in the plenum. And the plenum is just floating inside the wall cavity there, not really secured. And every time that indoor blower comes on, it is creating so much negative pressure in that closet. And instead of pulling it from the return air inside the space, it's going to pull it right from here. Infiltration is one of the biggest struggles that we have at Friedrich Air Conditioning with the VRP. And providing the proper techniques and providing the proper information, we're hoping to get this problem a little bit under control. So through knowledge and through our experiences, we hope that you guys will take this back to your installing mechanical contractors and let them know the importance of a good envelope seal. So Speaking about envelope seal, let's take a look at the second case study, which is envelope pressurization. So as good of a seal as we get inside our unit, it's not going to do us any good if the building is under negative pressure, right? So the VRP goes provide 35, 70, and 130 CFM depending on the size model, right? So in order to positively pressurize a space, those figures have to go into the load calculations of the building so that this way the proper exhaust fans can be sized. So general rule of thumb here is that if you have a shaft style exhaust and you have no balancing dampers, you have no guarantee of proper pressurization. So I have an example here. So this is off of a schedule, and for the most part, the designer did a pretty good job of trying to keep the specs well within range, right? So shaft style exhaust to save from their money from their fire dampers. They put their exhaust pipe 22 inches from their penetration, and they did not install balancing dampers. So this preliminary deviation that they took here is really going to show itself in the future. So when we were called in to take a look at it, the property complained to us. They said, "Hey, Friedrich, extremely humid inside our spaces. We've checked our installation. We got really good seal. We really don't understand what's going on." So when we took an example and we hooded one of the rooms, we were looking at the hood from the exhaust fan at 73.5 relative humidity. And not only that, take a look at the CFM of this exhaust hood. So we went to the room that was highlighted, and being that the VRP is supposed to have a CFM of 70 CFM on the fresh air for the dual fan, you would hope that the CFM coming out of the exhaust fan would be slightly lower than that in order to maintain the building pressurization. But you can see here, we're looking at 101 CFM. So this room is under pretty good negative pressure. So 35 CFM of the VRP fresh air, 100 CFM of the exhaust air. The condition is a high room relative humidity, and our conclusion is this room is under extreme negative pressure. And basically what we are doing is we are pulling way much more fresh air out of that fresh air port than 35 CFM. So you could imagine all of the problems that could be had if your building pressurization is not correct. So that's why when we started off the case study for about envelope pressurization is to make sure that when you're doing a shaft style exhaust that you are using some form of balancing damper or some form of static bypass damper that can regulate the CFM. Otherwise, that CFM is going to be jumping all over the place and you're going to have unregulated exhaust air. So the CFM, so this VRP is going to put out a standard 3570 or 135 CFM out of that fresh air port under neutral pressure. The second we start to go into more of a negative pressure, you're going to see more fresh air, not only being pulled from the fresh air fan, but every nook and cranny you could imagine possible inside that closet if it's not sealed properly. So what this leads us to is our VRP startup program. So early in the presentation, we said the VRP startup program is our process here at Friedrich to ensure that the VRP is installed successfully. The program consists of a couple separate documentations here. So when you do sell a VRP property, you are given the documentation, and it will include an overview, phase 1, phase 2, phase 3, and a blank matrix. So the first thing that we're going to do once we receive it is a PO from you guys is we're going to assign one of our regional technical managers to contact you regarding that property. And we're going to get a pre-construction meeting. And what some of the things that we like to do is just to go over the documentation, make sure that all your questions are answered, or if you have any overarching concerns about the property that you're doing the job on, that we can help you and address those concerns. So the first document is phase 1, and phase 1 is basically the acknowledgement of the startup program and the installation IOM requirements. So what this phase entails is this is a email, this is a conversation, this is a phone call between you as our manufacturer's reps and the installing entities that are on the job site to ensure that they have copies of the installation manual, to ensure that they understand the installation manual, they understand things like envelope sealing, they understand things like plenum sealing, and they fully understand that the VRP needs Cat6 stranded and shielded wire in order to operate, not 18-4 thermostat wire. So what this form is an acknowledgement that the entities on the site have received all those documentations and they understand them. The next document is called our Phase 2 mockup. So what this basically is the mechanical contractor installation training. So with every VRP order, we're going to send you 1 or 2 units. That's going to be considered your mockup units. So those units are going to be sent to the job site. So this way you can train the mechanical contractor on how the VRP is installed. So there is a checklist here that basically goes through some of the things that we touched on regarding installation here to make sure that the mechanical contractor installing the unit is pretty clear on how the units are installed. So once the checklist is completed, you as our manufacturer's reps are satisfied that they know how to install the units, they go and they sign off on a documentation, and then you would send it to us. One very important thing to note is that we cannot send you the rest of your equipment until we receive Phase 1 and Phase 2 documentation. So in order for us to release the equipment, you would have to be able to provide us the Phase 1 and Phase 2 documentation at least 2 weeks before your anticipated receive date. Now take note that you can do your Phase 1 and Phase 2 training either at your rep agencies, place of business, you can do it on an offsite trailer if needed. We just want to make sure that the entities that are putting in the equipment know the pitfalls and understand how critical it is about how the plenum is installed and about how the unit is installed. So necessarily doesn't have to be on the job. It can be off the job, just as long as you feel comfortable with the knowledge of the mechanical contractor. So once you send us the paperwork back, we release the shipment, and then the units are going to get shipped to the job site, and they're going to be installed, and then all the magic is going to happen. Later on in the project, they're going to be ready to start up the equipment. So our Phase 3 is a documented startup of all the VRPs accompanied by a matrix. So what this is going to do is to ensure that each VRP has been documented, that it has been started up, that it is running in both heating and cooling, that the fresh air fan works, that the indoor blower works, and that the wall controller works. And this is basically a verification checklist by serial number on the property to ensure us that every unit was started on the property 100%. And if there is a unit that did have a particular issue, we're able to pick up on those and address those through the warranty program before the property opens. So once you're ready for startup, you send an email to us, and the email is at the bottom of each form. It's vrpsupport@friedrich.com, and we will send you a pre-populated site matrix with all of your serial numbers and software versions so that you can easily take this to the job and you can complete your startup. Once you complete all the documentation, you send all the documentation back to us, and then we activate the warranty for you. So this year in 2020, we started to do something a little bit different. So some of our manufacturers representatives have come to us and says, hey, Friedrich, you guys really know your product. We would rather have you guys on the job, just supervising and doing all the training and taking care of all of the paperwork for us. So this year, we have decided to roll out a Friedrich factory-led startup program. So what this program entails is that a Friedrich technical manager will become the project manager for the support function of that site for the VRP installation and startup. So we're going to provide on-site mechanical contractor installation training and certification. We're also going to provide the technical guidance for the project management inquiries that we get either from the general contractor or the mechanical contractor. We will complete all the phase documentation, including startup, on your behalf, and startup, inspection, and verification of each VRP on the project will have the peace of mind knowing that one of our technical managers who have seen thousands of VRPs have looked over your job and has given it the thumbs up. We've done a couple recently, and we've seen some very good results from it. So if you guys are interested in that, please send us an email at vrp_support@friedrich.com, and we can provide you with the information that you need. If you don't need us to do the startup for you, but you would like us to attend the job site and to do a 1 or 2 day training for either the mechanical contractor or for you guys as manufacturers representatives, definitely also send us an email, and then we can definitely quote you to see how much it would be to get a technical manager out there for a couple days. So that's about all I have for today. I want to thank everybody for attending this webinar. I hope you guys picked up a couple good tips and tricks about how to install the VRP and a couple of those pitfalls to look out for. Thank you very much and enjoy.